Now let us start. Now, now let us start again. Yesterday, we have explained some other concepts. Third topic. Now, starting with this one. What is the validity using truth tables? And we have explained the conditions of validity using the truth tables. And according to that, here some of the examples is also here. Okay, what are the examples? Here H1 and H2. Now there are two conclusions here, and according to that, H1 and H2. One of the parties here. Now that approaches to the conclusion, how to find out the conclusion of this part. Now at the same time, some other practice problems are also mentioned here. Okay. Now what is that? Now law of inference per statement logic. Now modus ponens law of detachment. What is the modus ponens law of detachment? How to explain this one? If the statement in P is assumed as true, okay, any one of the statement that the statement have assumed as true and the P conditional Q is accepted as true, then Q is also true here. Okay. Symbolically, we have the following pattern. P conditional Q means what is the P? Is the theoretically it is impossible to determine a finite number of steps so that the conclusion follows from a given set of pieces by constructing the truth table. Now this method becomes tedious when the number of atomic variables present in all the formula representing the premises and the conclusion is large. Okay. Now here. Okay. Now, that conclusion we shall now establish the following law of inference, which provide the necessary justification for the steps in the derivation. This is the calculus, inference calculus part. Calculus means there is a combination of differentiation and integration, and in the same time, derivation means there is the various variation of this given atomic variables from one to another one, and they become the criteria for determining the validity of the arguments. And according to that, here modus ponens law of detachment. Okay. Now this is the one of the important concept here. Here P be any one of the statements that is like assumed as true. P conditional Q is accepted as true. Yes, P conditional Q is accepted as true. Then Q is true. Symbolically, we have the following pattern. Okay, symbolically, we have the following pattern. P implies Q means PQ here the P approaches. We are taking the P and given the result is Q is here. Now the rule of detachment or modus. Now this rule is also called detachment rule. Whereas modus ponens is a valid inference, That is the valid inference because P and of P to Q. P and of P to Q here. Now here the concept is just you have to see this one. Yes. Now This is the P implies Q, means P to Q. That is the P. If P is first also, P assumption is true. Automatically Q is also true. The rule of detachment or modus ponens is a valid inference because P and of P to Q. Now that is overall the result, we are giving the result is Q. That is the tautology. Yes. Now, if the P is true, that is the assumption of P is true, and we are getting the result is also true. Now both are true is there, that is the tautological expression. Now here the rule is called detachment or modus ponens. Okay, that's enough. If here, then one of the example here, modus ponens example here, if today is Thursday, yes, today is the Thursday, and after the next 10 days, from now will be Sunday. Sunday. Okay. Now suppose this day is also Thursday. After 10 days, the coming of the Sunday of the is there. Now today is Thursday. 10 days from now will be Sunday. This is the one of the statement is there. Today is the Thursday. Thursday is the one of the statement. So I will present here. Please raise your hands. Are you follow here? Arvind sir, please express your presentation. Okay, that's it. Thank you. That's it. Okay. Now, just how to only we will discuss 15 minutes this concept inference of calculus of part is there. Now, according to this one, the rule of detachment or at the same time the detachment of the rule is also called modus ponens. Now, here one of the example is say here, P statement is today is Thursday, and after 10 days, that is from now this day calculated is calculated from now will be Sunday is there. Okay, that is the Q statement is also true. P is true. Actually, this day is this day is Friday. Okay, in generally. Now, after 10 days, what is the next day? Monday is there. After 10 days will be Monday is there. Now, in the textbook example is also we have explained. Now, this example is also called from the modus ponens. Next one. Now, second person is also there. Now, one is the Galaxy A32. Okay, that's 1.2. Next one, definition. Another definition is also there. Just we will discuss only 15 minutes from the block 1 and the block 2. Next 45 minutes is also we will explain the block theory is there. Okay, please be patient. Next one, next definition is hypothetical syllogism. Now, this concept is also very important concept. Hypothetical syllogism. That is the transitive rule is there. Hypothetical syllogism there. Now, this property is also called the transitive part. Now, PQR, these are all three propositions here. Now, just you have to see the two carefully here. There is one of the tautology, P implies Q. That is a P conditional Q, and Q implies R. Okay. Galaxy A32. Are you clear? Are you clear? Hear me? Please respond. Hello? Can you hear? Please respond. Are you here? Hello? Hello? Okay. Please respond, madam.
ఇప్పుడే జాయిన్ అయ్యాం సార్. సారీ, ఇప్పుడే.
ఓకే, జస్ట్ 15 మినిట్స్ మనం ఈ యొక్క కాన్సెప్ట్ కంక్లూజన్ ఇచ్చేద్దాము. Then after that, remaining 40 minutes we will explain the graph theory part. Okay?
Okay, sir.
Okay, thank you. Next one, this concept is also very important. Okay? This is a hypothetical syllogism. What is the hypothetical syllogism? Okay, that concept is also called transitive rule. The tautology here PQR. There are three propositions here. Now here P conditional Q and Q conditional R is there. That is the negation. Now that conditional part of P to Q. Suppose P to Q is there. What is the transitive rule? P implies Q, Q implies R, and again That is the P implies R. That is called hypothetical syllogism or transitive rule. Now, in the expression can also be written as this part is there. Okay, clearly you have to show here P implies Q, P implies R, and therefore P implies R. Now, here one of the example is here. Now, that is in 1980 was a leap year. In 1980 was a leap year. Then 1984 is also a leap year. 1980 was a leap year, means that is the proposition is P. 1984 leap year is the proposition is Q. And what about the R? 1988 was a leap year, that is the Kepler. So 1980 to 1984, 4 years there, that is the leap year. P implies Q is there. 1984 to 1988, that is also 4 years coming is also leap year is there. That is the Q and R, Q conditional R. And at the same P implies R means 1980 was a leap year. At the same time, that proposition is P, 1980 was a leap year. And final conclusion of the proposition is 1988 was also a leap year. That is the preconditional R. So this is the expression. This rule is called syllogism. What is that? This is syllogism. That part is also called transitive rule. Okay, that's enough. Now here, what are the De Morgan laws? Okay, what is the De Morgan law? Negation of P and Q is a biconditional part of negation P or negation Q. And at the same time, negation of P and Q. What is that expression? Biconditional of that is equivalent to negation P or negation Q. Now, these both rules are called here the conjunction is the biconditional is also applying, or the equivalence condition is also applying. Now, that is the negation P, and the negation of conjunction is disjunction part, and the negation Q is here. Okay. At the same time, we can also be written here. Now, alternative part is there. Negation of P or Q. Just you have to rectify this one. Okay, both are same here. Both examples are same. But here the De Morgan laws. Conclusion of the negation is disjunction, and the disjunction of the conclusion is disjunction. Negation of the disjunction is conclusion. But here both are same concept here. Now just you have to change in your textbook. This is the V. V means R. Negation of P or Q is then equal to negation P and negation Q. That's enough. Now what is the contrapositive rule? Okay, this is also one of the important concepts. Okay, please stay on the line. This is also one of the important concepts. Okay, next one. What is the contrapositive? P goes to Q. If and only that is an equivalent to. And at the same time, both sides are contrapositive, means both sides are applying the negation part. And now last one is the last proposition must approach as the first proposition, negation of the first proposition. Now negative of Q and the negation of Q conditional to negation of P. Now we are taking the P conditional Q is here. Okay. At the same time, biconditional is also applying here. Now that is an equivalence of the part. Preconditional Q is the contrapositive expression is negation Q is conditional to negation P. Now this is the modus tollens. This contrapositive rule is also called say clearly conclusion. Every one is also another name here. Now this contrapositive rule is called modus tollens. Okay, it can be written as preconditional Q is here. Now applying the negation Q is there. At the same time, negation Q applying and the reverse part is also, we are getting the first proposition of the negation is here. We are getting the first proposition of the negation. Now this rule is also called. Now you have to express in final exam, symbolic representation is also presented here. Okay, there is no problem. Now we are getting the negation P. ఈ P conditional Q అని తీసుకుంటే Q false అయిందనుకుంటే P కూడా అవుతుంది, false అవుతుంది. This rule is also called contrapositive rule అని చెప్పి చెప్పచ్చండి. దీన్ని modus tollens అని చెప్పి చెప్తున్నాను నేను. ఇంకా example is there. See this example. State the contrapositive to the following. State the contrapositive to the following. Suppose if ABC is a right angle triangle, a very good example is there. Already we have to learn in previous process. What is the Pythagoras concept? In a right angle triangle, the square of the hypotenuse must be an equivalent to the other two sides of the sum of the other two sides of the square of part. Okay. Now the square of the sides, the sum of the square of the other two sides. Okay. Square of the hypotenuse is an equivalent to now square of the other two sides of the summation. Now that is called sum of the other two sides, sum of the squares of the other two sides. This is the Pythagoras concept. This example is also, then you have to write the contrapositive expressions here. Okay. Now in the right angle triangle, this is the right angle triangle. Just you have to this one. Okay. Now in this right angle triangle, this is A, this is B, and this is the C is there. Now angle B is 90 degrees here. Now what is the Pythagoras concept? AC square equal to AB square plus BC square. That's enough. Now the solution is just you have to observe contrapositive expression. Now mod AB square plus mod BC square not equal to mod AC square. How to express the reverse statement? Right angle triangle avvalante manaki hypotenuse square of the hypotenuse is equal to square of the sum of the other two sides equal avvali. ఎప్పుడైతే ఈ AC square not equal to AB square plus BC square అయ్యిందో at the same time that is not a right angle triangle. ఎప్పుడైతే ఇది పాసిబుల్ అవ్వలేదో ఆటోమేటిక్గా రైట్ యాంగిల్ ట్రయాంగిల్ కాదు అని చెప్పి ఈ కాంట్రాపాజిటివ్ ఎక్స్ప్రెషన్ మనం చెప్పొచ్చండి. నెక్స్ట్ వన్ అనదర్ డెఫినిషన్ ఈజ్ syllogism. Very important. What is that? Syllogism. Disjunctive syllogism. Disjunctive expression is here. Now we have to express the in between two propositions P or Q. Syllogism means second proposition of the negation is also applied here. That is the first proposition of the negation is there. We are getting the second proposition. Disjunctive part is now P or Q is one of the parts. And the negation P is also applied here. And again we are getting the result is therefore second proposition here. Okay, that is called disjunctive syllogism. Now that's good. And dilemma. Dilemma means too careful. Here, see this one. Dilemma means dilemma can be written as P or Q. Okay, that's one. What is the P or Q? Disjunction part is also mentioned that these two propositions in between. Now P goes to R, Q goes to R. There are three propositions, but you have to express the disjunction in between the disjunction two propositions here, P or Q. Suppose another proposition is there, capital R with another proposition. P goes to P is P conditional to R, Q conditional capital R. We are getting the result is capital R. That is another proposition is also final result is here. That is called the dilemma. Okay, law of contradiction is there. There are this one is also very important. Simply we can also written as law of contradiction. Negation of P goes to F naught. Okay, what is the F naught? F naught means that is the contradiction part. P denotes an arbitrary statement. F naught a contradiction. Now we have to verify the negation P goes to F naught and at the final result goes to given the proposition. That is the tautology. Suppose P be the one of the statement here and the negation P you have to apply the false statement, contradiction of the part, and that is also goes to giving the proposition. So that is the tautology expression is there. Now this law tells us that if P is a statement and negation P goes to F naught is true. F naught is true. Then negation P must be false. F naught is also false. But even the proposition is true. Then this law of inference is called the law of contradiction. Law of contradiction. Simply written as negation P goes to F naught and therefore we are getting the result is capital P. That is the rule of contradiction, is the basis for establishing the validity of an argument called the method of proof by contradiction. So this is the important concepts in the above syllogism and what is that? Dilemma, syllogism and the contrapositive rule and the De Morgan laws and etc. Hypothetical syllogism. Okay, syllogism. That rule is also called a transitive rule and at the same time modus ponens. Okay. Now these expressions must be important given this part. Okay. That's it. Next, at the same time, we have to observe this one, this table. We list all laws of inference in the following table. What are the laws? Here the first one is the law of inference. P goes to Q. Suppose P is one of the statement and Q is also, and we are getting the result is Q. Now what is the related logical implication? So the implication meeda ee preconditional Q nu ఏ విధంగా చెప్పొచ్చు? P conjunction of P to Q. Just you have to observe this column. Now P conditional, P conjunction of P conditional Q approaches to Q. That is the related logical implication. This rule is also called rule of detachment. The above concepts we have to mention here. Okay, in the tabular form. At the same time, just also repeated once. Now, suppose P conditional Q conditional R. This is the transitive expression that is also called hypothetical syllogism. Next one. Now, P conditional Q on the Q negation Q is also applied, and the final outcome result is negation P. This result is also called modus tollens. Now, these expressions, and the fourth one is also there. P and Q is here. We are getting the result is P and Q. This is the rule of conjunction. Now, in examination is also given just a list of all laws, all the laws of inference in the tabular form. So now write this type of answer is here. Okay. Now this is the disjunctive syllogism. This is also proved. Rule of contradiction. This is also here. Rule of conjunctive simplification in the expression is this of P and Q is there. We are getting the result is P, and it read as P and Q. Logical part is logical implication. It read as this type of the part. P and Q is the conditional implication of P. Now, rule of disjunctive simplification. P goes to the result is P conditional of P R Q. Okay, this is the logical implication. P and Q expression in the same manner. P and Q and of P conditional of Q conditional R. This is the rule of conditional part. Okay. Now at the same time, suppose this in the bracket expression second part is we are getting the result is capital R, and this type of logical implication is goes to capital R. This expression can also be written as here the substituting. This result is capital R. Now that result is also substituting here. We are we are getting the result is when the logical condition is capital R. That is the proof. Okay. Now this is also short notes is also given this type of rule of proof by cases. Next, rule of dilemma is also expressed here. P to Q, R to S, and P disjunction of R. At the same time, P disjunction R means the dilemma part is Q disjunction S. Now, the expression logical implication expression is P goes to R and R goes to S, and P disjunction of R. We are getting the result. The logical implication is QRS. That is the constructive part. This rule is called write the rule of dilemma from the expression. Means now this type of answer is there. Okay, this one and this one. Now it read as logical implication. It read as this type of people. Now that is the construction. Okay. Now last one is also rule of destructive. Destructive means negation is also applied under P to Q and R to S, and the negation Q under negation S. This replacing of this one is this one. That is the difference between rule of dilemma and the rule of destructive. In the replacing of P R capital R by negation Q or negation S. Finally, you are getting the result is negation P or negation R. Okay, that's enough. Check your answers. Now, just as one of the example is there, H1 and H2 is given. 2 plus 3 equal to 7. This is the false part. 2 plus 4 equal to 6. This is the true. False and true is also true. Okay. What is the expression of H1? That is the fill in the blanks. Just you have to observe 2 plus 3 equal to 7. Is it true? That is not true. So this is the false statement. proposition. 2 plus 4 equal to 6. Yes, this is the true proposition is there. Now one is the false and one is the true. So the implication result is we are getting the final result is true. Now 2 plus 3 not equals to 7. So simple connected is H2 part is here. Okay. Now H1 and H2 are also mentioned here. According to H1 and H2, 2 plus 4 not equal to 6. Okay, this is the conclusion of this part. Okay, one is false and second one is true. Okay, that's it. Now here in the H2 is also 2 plus 3 not equal to 7. This one is true, this one is false. Now we have to express the true and false. What is the conclusion of the H1 and H2? From the beginning we have to explain H1 and H2 means the and expression me in conjunction lo chepparu. నేను అక్కడ కండిషన్స్ చెప్పేటప్పుడు ముందర H1 లో ఉన్నటువంటి ఆ ప్రపోజిషన్ లో ఆ ట్రూ వాల్యూస్ మనం గమనించాలి. ఆ ఎక్స్ప్రెషన్ ఇక్కడ అప్లై చేయాలి. ఇక్కడ H2 లో కూడా ఉన్న ఎక్స్ప్రెషన్ గమనించాలి. దిస్ ఇస్ ఫాల్స్ అయింది. ఇక్కడ ఏమైందంటే ఫాల్స్ అండ్ ట్రూ. ఫాల్స్ కండిషనల్ ట్రూ అయితే అది ట్రూ అవుతుంది మనకి కండిషనల్ పార్ట్ లో తెలుస్తుంది. ఇక్కడ ఈ H1 H2 మధ్యన ఏం చెప్పాలంటే కంజంక్షన్ చెప్పాలి. చెప్పినప్పుడు ఆటోమేటిక్ గా ఏమవుతుంది false అవుతుంది. అంటే 2 plus 4 not equal to 6 అనేటువంటి మాట కంక్లూజన్ గా వీడు ఇక్కడ చెప్తున్నాడు. అర్థమవుతుందండి? Next in the same manner, this is also example. See this topic, end of this topic, compare the result. Okay, comparing your result. That's enough. Validity using the rules of inference. Okay, just you have to see this one because some time is also there. Graph theory also can be started here. Now, finally, validity using the rule of inference. We now describe the process of derivation by which demonstrates that a particular formula is a valid consequence of a given set of premises. Okay. Now, we give two rules of inference, which are also called rules P and T. Okay. Now, with validity using the rule of inference, how to explain this one? First of all, the process of derivation by which one demonstrates that a particular formula it is a valid consequence of a given set of premises here. Okay. For this, we give two rules of inference. What are that? Rule P. A premises may be introduced at any point in the derivation. Okay. A premises may be introduced at any point in the derivation. Rule T. A formula S may be introduced in a derivation if S is tautologically implied. S is tautologically implied. Any one or more of the preceding formulas in the derivation. Preceding formulas of the derivation. Okay, here you suppose U is a valid conclusion from the premises. P goes to R and Q goes to R and S. And the negation of R, this example, see here. P goes to R. Is it valid conclusion? So that U is a valid conclusion from the premises. Premises is also given is there. P and T. Now we are getting the result is U. U means valid conclusion from the given this premises. Premises 1, premises 2. H1, H2, H3. H1 means P conditional R, Q conditional R and S. Negation of R of negation T or U. Okay, that's enough. Now we are giving the result is solution. First one, there are three premises. Write the three premises over here. And just you have to observe this one. Given the premises, write the solution, first point, second point, and the third point. Now, first point is one of the premises, second point is one of the premises, and the third point, now P goes to, that is the transitive relation is there. Transitive rule is also applied, third point. P goes to P to Q, Q to R, and P to R is the transitive part. Here the P to R means P to P implies R and R, yes. That is the transitive rule is also applied from the two conditions. Okay. Next one, and the fourth point. What is that? P and T is given. Final conclusion is there. Okay, P and T means you have to, that is also one of the premise. Okay. Now, fifth one, where result is first proposition is capital P. Now, from fourth condition, what about the P and T? Already we have to explain the P and T here. Okay. The rules of P and T is called validity using the rule of inference. We are getting the result is, what is that? Capital P. From fourth condition P and T. Now given the value is true, that value and comparing with given the proposition, we are getting the result is the same proposition is here. Now the result is fifth point is 5. Now you have to mention the causes here from fourth condition. What is the fourth condition? You have to apply the by conjunction property. Now the result is capital P. Now every point is also mentioned this side. Now R and S, sixth one is there. From fifth and the third condition, what is that? Fifth and third condition, by modus ponens process, R and S, we are getting the result is capital R. That is also from sixth condition and by conjunction part. And at the same time, what is the other premise? Just you have to observe the given the question. Okay, this is the other premise part. Okay, the other premise you are taking the next point is 8th point. Okay, now this is the essay type question is there. There is no doubt. One of the important essay given this block. Okay, negation R, negation T or U. Now this part is also taken from the previous part. Given part is there. Now at the same time, distributive associative law is also applied. Negation R, negation T, and again R of U. Now from the 8th condition, we have to apply the associative property. Write this type of the associative condition from 8th point. Now at the same time, negation of R and T or U. This is the De Morgan law. This concept is called De Morgan. Negation is also common here. Negation is common. What is the R? Negation common is and so that is the negation of R and T or U by De Morgan law. Now observe this rule is called a negation of R and T or U means that is the true. Fourth condition by rule of conjective simplification. Conjective simplification is just me. We are getting the result is okay, true. Now from 7th and 11th point, write this type of here. What is the 7th one? Capital R. 11th point is capital T. We have to apply, we are taking the conjunction part is there. R and T. So this is the conjunction of the part means by 10th condition. What about the 10th condition? De Morgan law concept. So here according to this one, R and T, now 10th condition is also applied by distinctive syllogism. Means we are getting the result is U and future noun. Okay, that's it. Now this is the final concept mentioned here. Okay, this is the U. This is the noun. Next, here establish the validity of the argument. There are three premises here. First point, second point, and third point given in the solution. Premise. First point is the one of the premise. Second point is the one of the premise. Right, C here. Now third one is the Q. Okay, that is not a premise. Okay, now fourth one is also, now we have to apply the commutative law. According to the third condition, we have to apply the commutative law is there, negation S or P, that is the Q. Okay, and the implication, fourth one, by the fourth condition, implication is also applied. What about the in the relation of the S and P? S conditional P means negation S or P. We are here. Okay. Now this condition can also be written as S goes to Q conditional R. S conditional law, Q conditional law. The implication conditions need. Now conditional part from first condition, fifth condition, and according to that by transitive rule, you have to mention the 6th point. And from 6th point and by conditional proof, we are getting the result is here S and Q. According to the 6th point, now write the 7th point is here. Now that is S and Q of conditional capital R. And finally here, according to this condition, P conditional by this property, P conditional of Q conditional of P and Q. Okay, write this type of Q conditional of S conditional of Q and S. That is the commutative part. S and Q equals to Q and S. Okay, this is the now applying according to this one. Now 9th part is also it came from 3 and 8. That is the modus ponens method. Now modus ponens method, now this concept is Q goes to, that is the S goes to Q and S. Now we are getting the result is 7th and 10th turns to rule is also applied. 7th one this is, 10th one this is. Now 7th we are getting the result is S conditional or S implication R is there. Okay, so the total value is capital S. Now right here S goes to capital R, that is the third, the 10th point. Okay, now this is the inference calculus method. Okay, now derived from the premises. Now in the same manner you have to write this one, check your answers one again. Okay, what is the inconsistence means? Inconsistence or conjunction. Inconsistence or conjunction. How to explain the inconsistent? A set of formulas, we are taking the M type of formulas are there. H1, H2, and so on, HM. These are all the number of premises here. Now these are all set of formulas. In between, we have to express the conjunction is there. Now, according to that conjunction in between H1 and H2 and H3 and so on, HM. Now, this is the inconsistence means if their conjunction implies a contradiction. Yes, say here, conjunction implies a contradiction. That is, now how to write this symbolic representation. H1 and H2 and so on and HM, we are getting the biconditional part is equivalent, that is an equivalent to R and negation R. R and here, what is the R? R capital V in one of the formula is there. Now, R and negation R, there is a conjunction implies a contradiction. That's enough. Now, this is the inconsistent concept is here. Okay. Now, in inconsistent concept, proof of the contradiction. Okay. Now, additional premise is also taken in order to show that a conclusion capital C. C is one of the conclusions. That conclusion must be followed logically from the premises. What is the logical premises here? H1, H2, H3, and so on, up to HM values. We assume that here C is false, conclusion is false. First of all, conclusion is false means we have to consider the negation of C as an additional premise. Okay, that's enough. Now the set of premises of the new part is inconsistent and that implies a contradiction concept is there. Okay, then the assumption that negation of C is true does not hold simultaneously with in between the conjunction of the HM type of premises. Now, the set of premises that is also true here. Conclusion is true in between H1 and H2 and so on and HM. Okay, that is also true. So therefore, conclusion follows logically from the premises. What are the premises? This is the logically premises means H1, H2, so on, HM. Now that it follows from capital C, there is the conclusion part is also true here. Okay. Now this type of is also for the so many problems here. Use the method of proof by contradiction. Okay. This type of expression is there according to the negation concept. Okay. Now P conditional of Q and R conditional yes. Okay. Okay. P conditional of Q and R conditional yes. Now what about the what is the final result? Negation of these are two premises here. Another premises is negation of Q and S. Now these are two premises here. This is not a premises mentioned given in the solution. Now but here that is the one of the premise. What is that? P conditional of Q and R is one of the first premise. First point. R conditional of Q means R implication S. R implication yes, that is the second point. And the third premise is negation of Q and S. That is also third condition. One of the premises there. And now every time mentioned here, is it premise or how? What is the law applied in the right hand side? Okay. Now, which law is also applied in right hand side? Now, just you have to observe the model pattern is also there. There are a number of questions is given from the concept oriented. Okay. Now, which law is also applied in this part? Okay. Now, suppose you have to observe this one, third and the fourth one is also. What is applied? According to the third one, additional premise applied, we are getting the result is, okay, double negation. Fourth point is also applied. Negation of negation P. Applied, double negation. We are getting the result is capital P. Okay. That type of concept, that type of law of inference. Okay, we are getting the result is the final upcoming result is This is conclusion. P and negation P and biconditional part is C. Now each and every time you have to mention the which law applied, which law is taken, which is defined from. Okay. Now what are the laws applied here? Now you must mention that the right side of this part. That's enough. Now this is the main part is also. Now this problem is contrapositive argument to verify the valid inference. W goes to R goes to S. W implies of R implies yes. We are getting the result is this. Okay. So that is the implication. You have to express the now W, suppose W conditional R, W conditional yes, and finally R conditional yes, W conditional R. We are getting the result is W conditional yes is there. Now here, according to the what is that? Contrapositive argument. Now you write the preconditional Q. What is the contrapositive? Negation Q, implication, negation P. Okay. Now applying this rule, you have to give in this region. Okay. That's enough. We are getting the result is W and R goes to means W and R implies to capital yes. That's it. Okay. Now this theory is also there. Show that the following premises are inconsistent. Okay. This is also important. These session, we are giving the one of the premises part is also given in the final examination. Essay question is also given. Okay, this is also the above examples are also very too important from this session. Okay, no doubt. Okay, please check your answers. Now this is the end of the part. Okay, next one. This is the first block part. First block is also completed. In the second block, recurrence relations and recursive functions. Okay. Now we have to start the graph theory. Now from the first block, maximum number of questions is given in the final examinations part. Now each block, now one essay is given. Now first block is also you have to answer. There is no doubt because maximum part is completed. According to my effort here, there is no doubt. Now one essay is given, one essay and two short answers, and at the same time two multiple choice, and at the two multiple choice, two fill in the blanks, one match the following. Okay, that's enough. There are so many marks here. Okay, there is no doubt. But in the some important concept in the block 2 is also there. Now this type of mathematical induction is also well known here. Okay, just you have to attempt to only Bible and chapter ఉంటుంది అమ్మా ఒకసారి మీరు ఇంపార్టెంట్ నోట్ చేసుకోండి. ఓకే మేడం గారు ఎవరో నోట్ చేసుకుంటే మీకు ఈ మ్యాథమెటికల్ ఇండక్షన్ అనేది ప్రీవియస్ సెషన్ లో తెలుసు కాబట్టి ఇంకల్షన్ అండ్ ఎక్స్కల్షన్ అనేది పార్ట్ 2 దాని యొక్క ప్రిన్సిపల్స్ మనం ఇక్కడ స్టడీ చేస్తాము. And according to that, mathematical induction is also we have to construct it here, and we have learned many much more problems through the mathematical induction oriented. And how to construct the generative function, the recurrence relations. And next unit is the recursion and the recursive functions. Now, in this block especially, what is the counting numbers and the natural numbers? Counting numbers are at the same time is also called the natural numbers. That is set of 1, 2, 3 and so on. These numbers are called counting numbers. Now, in the set of natural numbers, the number of elements within the set is called mod A. Now that is notated as n of A. So one of the example is there. This is the ordered set. Okay, cardinality. Ordered set is that is the cardinality set, and sometimes that is also called cardinal number of A or cardinality set. That is the number of A, means n of A. Now there are already have learned in the set theory oriented is there. Suppose n of A, B, any two sets is there. Now we have to find out the A union B and A intersection A union B. How to find out the A union B through the A intersection B part. Okay. So what is the A intersection A union B formula? N of A union B equal to N of A plus N of B minus N of A intersection B. Now that type of problem is also given in the model paper is also there. See this one, that is also match the following. In sometimes just you have to depends upon your page. Now in sometimes short answer is also given here. Okay, there is not. Now two sets have no common elements. You just you have to observe this one. Two sets have no common elements. That is also then they are said to be disjoint sets. If more number of sets have no common elements, then they are said to be pairwise disjoint sets. Suppose you have to observe these three sets. Pairwise disjoint sets. These sets are given. Now one is not connected to the another one. A and B. You have to observe. There are no common elements. B and C are just you have to observe. There are no common elements. Now you have to observe these three sets. There are no common elements. So these three sets are pairwise disjoint sets. In probability concept is also there are two events here. Even and E1 and E2 are said to be mutually exclusive. What is the meaning of mutually exclusive? If E1 or E2 define mutually exclusive events. If E1 or E2 can happen, but both cannot happen simultaneously. Okay. Suppose one of the example is there, tossing of a coin. Coin means now you are getting the result is either head or toss. At the same time, both are not possible here. Okay. We now state two basic counting principles. One is the sum rule and the product rule. Okay. Both are heads. How many chances are there? Both are heads. At the same time, one coin getting the result is either head or tail. Okay, that's it. Now, what is the sum of the rule? Already, this is also well-known part in set theory and probability concept is there. What is the sum of the rule? N of A will be equal to N of A plus N of B minus N of A intersection is there. According to that, there are number of sets, disjoint sets here. There are no common disjoint sets, pairwise disjoint sets. There is no common elements here. Now in between A1 and A2, A2 and A3 and so on, AN. Okay. Now applying the cardinality concept, mod A equal to mod A1 plus, mod A2 plus, mod A3 plus 1 plus mod AN. Now that is the already mentioned here. Now these sets are non-empty sets having no common elements. This rule is also called, what is that? Sum rule. The rule is also called sum rule. Which is also known to be principle of disjunction counting. Disjunction counting, because union represents OR combination. This is what is the distinction of the part. Just a minute, please. Okay, there is no. Okay. Next one. What is the principle of disjunctive counting? The same principle can also be stated in terms of events as below. Principle of disjunction counting or sum rule. Okay. Now, sometimes that is also called Hooker set. The same principle can also be stated in terms of events. In events, first event of the number of phases is M1. Second event of the number of phases is M2, and the nth event now it can happen n type of number of ways, Mn. Okay. Now E1 or E2 or E3 or so on, En. Okay. Right type of this type of mutually exclusive events. Now these events are mutually exclusive. E1 can occur in M1 number of days, E2 occur in M2 number of days, so on. En can occur in Mn. Okay, En Mn represents the number of days. Okay, there are simple examples just to have to observe this one. In how many ways can we get a sum 4 or 8? Two distinguishable dice are rolled. Okay, now these problems are also well known. Suppose how many ways can we get a sum 4 or 8 when two distinguishable dice? ఏ రెండు డైస్ తీసుకున్నప్పటికీ కూడా ఆ రెండిటి యొక్క మొత్తము 4 గాని లేక 8 గాని రావడానికి ఎన్ని ఛాన్సెస్ ఉన్నాయి అని చెప్పి అడుగుతున్నాడు. Now here x1 and x2. Now little bit mistake here. x1, this is x1. Okay, x1 and x2 represent the outcomes when the first and the second dice. Now dice, the number of cases are 6. 1, 2, 3, 4, 5, 6. Now you have to observe the already you have learned in previous classes in probability concept is there. Okay, that is the mature concept. There are number of examples here on the dice part. Okay, now second dice are rolled respectively. Thus x1 can take any value from 1 to 6. x1 1 to 6 is 20. So as x2. Okay, even be the event of getting sum. Even the event is put as what you from మొత్తాన్ని x1 plus x2 equal to 4. Okay, which can happen 3 ways, namely first dice 1, second dice is 3 is there. So 1 plus 3 is 4 by this expression. Okay. Now first day's outcome result is 2. Second day's outcome result is 2. Now some of the addition rule is also applied. That is also 4. We are getting. First day is 3. Second day is 1. 3 plus 1 is 4. Okay, that's enough. Now here that E to be the one of the event of getting sum is x1 plus x2 equal to 8. Some of the events is also 8 means there are 2 days here. 2 days must be rolled here. One of the way is 2. Second days is also 6. One of the way is 3 and second day is 5 and first day is 4. Second day is 4. There are number of ways here. 1, 2, 3, 4. This is the 5 expressions here. Now in the sum of we getting the result sum of 4 is there are 3 chances here. Sum of the 8 is there are number of chances is 5. So overall the result is some rule is also applied here. 3 plus 5 is 8. That is the number of ways of getting 4 or 8. Okay, that's it. So there are so many examples. At the same product rule is also applied. Now there is a clear part is here. There is no doubt. Product rule is also can also be written as A1 cross. Now A here the number of elements is 3. B set is 2 elements here. Cardinality A is 3. Cardinality B is 2. 3 into 2 is 6. 3 to 2 is 6. Now here A cross B. Okay. Now A cross B means they are related to B. 1 goes to 4. 1 goes to 5. 2 goes to 4. 2 goes to 5. 3 goes to 4. 3, 4, 3, 5. These are all ordered pairs from the A and B sets. Now here applying the ordered pair relation is the cross. Now in sometimes that is also called some of the mathematicians also represented as A to B here. Now that is n of A equals to mod A. That value is 3. And n of B equals to mod B. That value is number of. What is the cardinality? There are 2 elements here. Now there are 3 into 3 outcomes. The result is 6. 1, 2, 3, 4, 5, 6. There are 6 ordered pairs given in the A cross B relation. Now finally ordered cardinality of A cross B equal to mod A into mod B. So the final result is 3 into 3 is 6. No? So there n type of extended number of sets is A1, A2, so on, AN. Now enter this part can also now it read as product of AI. In also sequential counting law, product of AI got also. This rule is also called principle of sequential counting. There are so many examples are also here. Okay, this is also well practiced. Okay. The principle of inclusion and expulsion. Now, this is the important concept in the final examination. A and B are subsets of the universal set U. What is the cardinality of A and B? Cardinality A plus cardinality B minus cardinality of A intersection B. Now, in sometimes it read as number of A and B equal to n of A and B equal to n of A plus n of B minus n of A intersection B is there. Here A and B are subsets of the universal set. We are taking the A set and the B set in the Venn diagram is there. Now, the represented by Venn diagram. Now, this is the A intersection B part. This is the complement of A, and that is A intersection B bar. This is the complement of B. That is the A bar intersection of B. Read as A bar intersection of B. Now, these three, what is mutually disjoint sets? A intersection B bar, A intersection B, A bar intersection B. These are mutually disjoint sets. Now, we have the replacement of this one. Mod A and B equal to n of A can also be written as mod A intersection B bar. N of B can be this one plus some of these 3 ones. Okay. Now, this part can also be written as A minus of A intersection B. This part is in the same manner. Okay. There is no change. But this can also be written as B minus of A intersection B. Okay. Now, mod A plus mod A minus mod A intersection B plus mod A intersection B plus mod B minus mod A intersection B. Okay, that is the cardinality part. Now, after the simplification, we are getting the result is n of cardinality of A and B equal to n of A plus n of B minus n of A intersection B. Now, in sometimes that is also written read as cardinality of A and B equal to cardinality A plus cardinality B minus cardinality of A intersection B. Okay. Now suppose A and B are any 2 disjoint sets. Now getting the result is A intersection B equals to 5. Now that value is A intersection B equal to, at the same time the value is 0. Now principle of inclusion. Inclusion means that is the in between of this part here, and exclusion reduces to, okay, inclusion and exclusion reduces to mod A union B equal to when here both are disjoint sets, the replacing of the value A intersection B equal to 0. Finally, we are getting the result is mod A union B equals to mod A plus mod B. Okay, that's enough. Now this rule is called the principle of inclusion and exclusion for 3 sets. Now the above concept is we have to represent it for 2 sets. This is 3 sets. Already the entire these expressions practice we have learned in the previous classes. And at the same time, the high school school level and upgrading level is also probability concept is also there. In intermediate section or degree section is also there. Okay. Now here A, B, C are any 3 subsets of universal set capital U. Then mod A union B union C equal to mod A plus mod B plus mod C, or N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus mod of A intersection B intersection C is there. Suppose A, B, C are 3 mutually disjoint sets. Suppose mutually disjoint sets means these values are 0. At the same time, this is also 0. Now, what about the result? If these sets are mutually disjoint sets, we are getting the result is cardinality of A union B union is equal to cardinality A, cardinality B, cardinality C. Now, you are taking the number of values are there. That is the n type of sets are there in the universal set. Okay, that is the general statement of principal inclusion. Write the general statement of principal inclusion is this type of there. Now, cardinality of union of AI, here I represented as 1 to m values. Now, at the same time, the overall the result is A1 plus A2 plus 1 AM. That must be equal to summation mod AI. Here I is taken from 1 to m minus summation I and j is also AI intersection AJ. Suppose 1 and 2. This is 1, 2, 3. Plus summation means overall the values of their intersection. 1 and 2, 2 and 3, 3 and 4. Okay. Now this type of expression is here. Plus summation overall the values up to k values. Finally, that is also applying minus 1 whole power n minus 1 of cardinality of A1 intersection A2. Now this type of expression is called general statement of principle of inclusion. Okay. Suppose that this is also mutually disjoint sets up to n sets are mutually disjoint sets. There is no intersected values not mentioned here because that those values are 0. We are getting the result is if all the sets are mutually disjoint sets. Now then their expression is this is mod A1, mod A2, so on mod AM. Union represented as the summation of this part here. Okay. Now this problem is also given in the given in your model paper. In the just you have to see the final PDF is there. Now that is the material is there. Now end of this part paper is given. Now the paper is also giving this example mentioned. Okay, that's enough. This example, especially. Mod union as in a college 200 students can speak Telugu. Okay, at the same time 70 students can speak Sanskrit. N of t equal to 200, n of s equal to 70, n of here while only n of t intersection s equals to 40. Yes. How many students can speak either Telugu or Sanskrit? Means find the value of what it will be. Yes. This is the represented as R. Okay. That's enough. Now this is the final concept. Okay. Final answer is here. That's enough. Now, in the same manner, from a group of 10 professors, how many ways can a committee of 5 members be formed so that at least one of the professor A and the professor B will be included? Just to see this example that is also given. Now, these examples are also very important. Okay. Finally, this is the Pigeon hole principle. Okay. What is the Pigeon hole principle? This is also one of the important concept in the second block. Okay. Now, this is the essay question, and some of the above part is also Essay questions are also given. Now, especially in short notes here, short notes are there. Now, this is Bayesian whole principle. This concept is very important concept. Okay. Now, the Bayesian whole principle is also known as Dirichlet principle. Yes, especially what is the Dirichlet concept? Okay, that is the box principle. At the same time, is also called in the examination. Write the box principle, write the Dirichlet principle, and explain the Bayesian whole principle. Both are all are same here. It is also one of the methods of counting. Now you are taking in any 3 boxes. Now just you have to insert the one by one is there. Okay. Now, the type of counting is also called a large number of objects are distributed into some specified number of boxes. Now, this concept represented as a large number of objects are distributed into some specified number of boxes. Okay. Then at least one of the boxes will contain certain number of objects. Just you have to observe this one. At least one of the boxes will contain certain number of objects. Here the objects are treated as Bayesians. Okay. Yes. And the boxes are treated as Bayesian holes. Okay. Just objects insert cheyali ante మనం చూడండి హోల్స్ లో ఇన్సర్ట్ చేసుకుంటూ వెళ్ళిపోతాం. అలాగే మన నెంబర్ ఆఫ్ బాక్సెస్ ఉన్నప్పుడు వన్ బై వన్ అలా ఇన్సర్ట్ చేసుకుంటూ వెళ్ళేటువంటి చెప్పేటువంటి కాన్సెప్ట్ ని ఇక్కడ మనం ఏమని చెప్తున్నామండి, Bayesian హోల్ ప్రిన్సిపల్ అని చెప్తున్నాము. సో ఇది అట్లీస్ట్ వన్ ఆఫ్ ది బాక్స్ అన్నాము. వన్ ఆఫ్ ది బాక్సెస్ విల్ కంటైన్ సర్టెన్ నెంబర్ ఆఫ్, ఏ ఒక్క దాంట్లో అయినా సర్టెన్ నెంబర్ ఆఫ్ ఆబ్జెక్ట్స్ ని కూడా మనం ఇన్సర్ట్ చేయొచ్చు. సో దట్ ఈస్ కాల్డ్ Bayesian హోల్ ప్రిన్సిపల్. ఓకే, రిజల్ట్ తెలుస్తుంది. Madam, please respond this one. This way. Okay. Now here, Madam, follow Madam.
Yes, sir.
So can you hear clear?
Yes, sir.
Clear? Hello?
Yes.
Please respond.
Yes, sir.
Follow Madam.
Yes, sir.
Around the concept.
Yes, sir.
Any problem?
No, sir.
You have connection is unstable. Okay. ఒకవేళ ఎక్కడైనా ఆగిపోతే మీరు టెన్షన్ పడకండి. రేపటి క్లాస్ లో ఎస్పెషల్లీ నేను గ్రాఫ్ థియరీ చెప్పేస్తాను. సో సెకండ్ బ్లాక్ is also covered, maximum covered here. Okay. What is the Bayesian whole principle? This is the first form. There are number of forms here. First form, second form, third form. There are 3 types of forms in Bayesian whole principle. Okay. Now, first form is we are taking the n type of positive integers here. You have to write the n consisting of positive integers here. Some of the n consisting positive integers, and we are inserting the number of additional part. Up to n plus 1 number of objects are put into n boxes. Then either the first box contains at least m1 objects. Okay. Now, or the second box contains at least m2 objects. Now we are consisting nth box contains at least mn objects. Now first box m1, second box m2 objects, and nth box contains at least mn objects. Now you have to observe these boxes. Now you are inserting at least one box. In the additional part is also inserted here. Okay, that is the Bayesian whole first principle. Okay. Now by the method of contradiction, here the statement is number of in additional part is also number of objects are distributed into n boxes. Right, given the statement. P statement is this is. And what is the 2i statement? Ith box contains at least mi number of objects. Ith box contains at least mi number of objects. Now write the another proposition is there, q equals 2. Now 2i statement is there, can also be written as q equal to, in the distinction part is q1r, q2r, so on r, qn. Write the p conditional q. P implies q. Assumption that was truth table of p. What is the implication of this part? Here the mention is disjunction is there. And in the implication, we are converting into the conjunction of negation. That is P conjunction of negation Q. That is the proved part. Now here the assumption of in conditional part is that is the and of negation. Negation Q equals to negation of Q1R, Q2R, Q3R, or Qn. And at the same time, negation Q equals to negation Q1. Negation of disjunction is conjunction. Negation Q2, negation of disjunction is what is that? Conjunction, and up to n values. So now my negation of Qi represents Mi number of objects, and at the same time negation of Qi, ith box contain at most Mi of -1 number of objects. Now minus Q1, the first box contain less than or equal to M1 of -1 number of objects. So I equal to 1 is there. Here I equal to 2 is there. Negation of Q in the same manner. Q2 is the second box contain less than or equal to M2 of -1. Now M2 -1 is there. M2 of -1. Now in the same manner up to 2n. Nth box contain less than or equal to Mn of -1 number of objects. Now finally you have to substitution here, where the final result is number of objects that are distributed into n boxes. That is sum of the values. We are taking M1 plus M2 plus 1, Mn of minus of n plus 1 less than or equal to number of objects is M1, M2, so on, Mn of -n. So these values represented 1. Okay, the additional part is 1, but both sets are, this is the cancellation of this part. So we are getting the result is 1 less than or equal to 0. Okay, that's an answer. Now 1 less than or equal to 0. Is it true? This is a contradiction of the part. We are getting the value is true. Now we are getting the result is the contradiction here. Now finally P and negation Q is not true. Finally P and negation Q is not true means P conditional Q is true. Okay, that's enough. This is the Pizian whole principle. Okay, that's enough. Now in the same manner you have to see these theorems. Pizian whole principle 2, Pizian whole principle third theorem, and it depends upon the theorems. You have to practice the number of problems mentioned here. Okay, now this problem especially one important is there, and yes, the Pizian whole principle, one of the important essay in this especially second block in this final in the final examination. There is no doubt. Okay, thank you. Okay, next one. This is the concept. This is the mathematical induction is also there. That mathematical induction you have to practice method of improvement. Now what is the mathematical induction? Suppose P of n is the statement. Okay, P being one of the statement. Now that the statement n equals to 1, because natural numbers is also comes for 1, 2, 3 and so on. Now P of 1 is true, P of n is true, implies P of n plus 1 is true. Now that expression at the same time P of n plus 1 is true means n plus 1 being a natural number is there. Now that is the concept of mathematical induction. Okay, that's enough. Now using mathematical induction, show that the sum of the first n number of natural numbers. That is, what is the summation of the natural numbers? N of n plus 1 by 2. Okay, first n of natural numbers expression. Now we have to prove that through the mathematical induction. Okay. Now given the statement. Now in examination is given this type or this type. So that 1 plus 2 plus 3 plus 1 n equals to n of n plus 1 by 2. For all n being a natural number. Okay. Now the given proposition is, what is that? That proposition now write as P of n. Put n equal to 1. Now that is also satisfied. We are getting the result is 1. Okay, put n equal to 1. So overall the value is 1. We are taking the only one value is there. Okay, LHS is equal to 1. In RHS, this is the LHS part, this is the RHS part. Put n equal to 1 is there. 1 of 1 plus 1 by 2. Now that result is also 1. So finally, P of 1 is true, P of n is true, P of k is true. At the same time, P of k plus 1 is true. The replacing k plus 1 by small n. So finally, we are getting the statement is P of n is true. Okay, by mathematical induction, the result is true for all values of n. Now you have to see the so many examples. Some of the squares of natural numbers expression, that is summation I square n of n plus 1 and of 2n plus 1 by 6. This is also one of the example through the to derive and through the mathematical induction concept. Okay. Now this example 4.6.3 is also example. Example means now that expression is also important in the final examination. There is no doubt. Okay. Just to see how to see this one. To show that 2 power n is greater than n square for all n greater than or equal to 5, and being a natural number. Okay. That's enough. Okay. Now this is the end of the part. Now entire this concept must be depends upon the mathematical induction and inclusion and exclusion principles and the Piaget whole principles and mathematical induction concept. Now these expressions is also important in the final examination. Okay, and now there is no doubt. Now we have to verify as and clearly. Okay, just we have to run this black one essay is also given. Now first part is also 28 marks first block, second part is 25. We are getting the both blocks 53 marks is also scored in the final examinations. There is no doubt. Now tomorrow we will meet another concept, that is the graph theory. Now there is no doubt. Now all students must be present here. Now if not possible, just you have to see the YouTube and to learn and practice the as and clearly your doubts are also clarified according to my class. Okay, there is no thank you one and all.